Hello everybody, welcome to this electrodynamics series. Today I am starting the topic divergence. Divergence of a vector field. So let me just take a vector field, let's say V. Okay, so first let me write the name of the topic, divergence. So let's for example we are taking a vector field V. It has three components and each component can have dependence upon a x, y and z coordinate. So if we draw a coordinate system x, y and z, so if we try to if you want to draw this vector field V, so it will look like this. At different location in space or for the different values of x, y and z, the V vector, the vector field V would be different in magnitude and different in direction. Okay. So what is this divergence? Well, the name divergence itself says that how these vector field lines are diverging or converging, or they are neither diverging nor converging. They are just parallel. This each this lines are just parallel. So we can have three cases, right? This vector field lines is either diverging, converging, or none. So in the case of diverging, the value of the divergence that I'm going to tell you how to calculate it is going to be positive. Okay, and for the converging it is going to be negative, and for the none of the above case it is going to be 0. Okay. So divergence is defined by dot product of del operator with the vector field V, and if we want to calculate it, so we are writing this divergence. We are only taking x and y coordinate, although we can always take the g coordinate as well, but here we are just taking the x and y coordinate. Okay. V is Vx of x, Vy of y. I'm sorry, it is Vy of y. So this is dot product, so the only component will survive these two components. Okay, so the divergence will be given by this equation. Okay, so this is only true for the Cartesian coordinate system. For the different coordinate system, new different expression will be formed that I am going to explain in the curvilinear coordinate topic. Okay, yeah. So this if we have a vector field like this vector field will have positive divergence. This vector field have 0 divergence, and this vector field will have negative divergence. From the if you want to see the picture geometrically, so it is gonna be look like this. Okay, now let's come to the another topic, which is the curl of a vector field. similarly, the curl is given by the cross product of this del operator with the this vector field. So how to calculate the cross product? So we are taking x cap, y cap, z cap, and this del operator, their component will be written like this. And this component for the vector field will be vx, vy, and vz. So the final form would look like this: x cap vy plus, this is minus y cap, okay, del y del x vz minus del y del z vy, vx plus z del y del x vy del y del y vy. Okay, so this is the curl of a vector field V in the Cartesian coordinate. In the different coordinate system, the expression will look like different. Now, what curl physically represent? Well, it represent how much vector field rotates. Okay, so let's, for example, instead of this vector field, we are taking the specific example of vector field, which may be a motion of fluid. Okay, so suppose a water is flowing. Okay, so the molecules, the molecules of water is flowing. It not necessarily that all the water molecules will have the same velocity. So these molecules may have velocity like this. This molecules may have velocity like this. These molecules may have velocity like this. Okay. So and these molecules may have velocity like this. So the motion of water can be represented by vector field. Okay, so curl represent how much this rotation is there in the vector field. So that means if we are taking the stick, a wooden stick, and put it into the water, so is there a tendency to rotate this stick when we put it in the water, into the water flow? So the more the stick will rotate, the more curl of that, the more curl this this water this flowing water will have. Okay, so if we have water flowing like this, and of course when we put the wooden stick over here, it is not going to be rotated. It always move in the forward direction. Okay, so in that case we have curl equal to 0. If we have a vector field like this, or the water will rotate like this, like in a vortex or a cyclone, then when we put the stick over there, it is definitely going to rotate. In that case the curl will be positive. Okay, and if it is moving in the counterclockwise direction, instead of this, if it is moving in the clockwise direction, okay, so it is going to be, curl is going to be negative. Okay, so the sign of this curl actually represent the the direction of the rotation.